大家好，我是 OBANA Kazuaki. So I'm sorry, I could speak Chinese just only several words, so change to English. And yes, so the time is very already exceeded. So I wanna move quick as much as possible, but first of all, I would like to introduce today's presentation. I would like to introduce our commercial deployment and also our expectation of the future core network. That is our today's content. And this is our experience in March. Oh, sorry. This is not good. Just a minute. Yep. This is our experience in March 2011. That was quite the terrible earthquake attacked the north part of the country. So the southern traffic came in, and also our network cannot serve such kind of the terrible traffic. So we would like to introduce NFB technology in our commercial data network. And our expectation is these four items. Already know the CapEx reduction and rapid service provisioning and improve connectivity and improve network reliability. And also, we think these interfaces are quite important for achieving multi-vendor environment. So we are thinking about this kind of interface is quite important for, and also these interfaces are quite important to leverage and reuse existing OSS and BSS. And this is current status of GSC for stage 2 in HISTNFB. And these all interfaces are already published. And you can download from each portal site. And this slide shows standard and open source, and we think these are complementary and accelerating each other. So at first, we would like to input the requirements from standard coding, and after that, OpenNFB could deliver solutions. So we are expecting the OpenNFB to make real and workable solutions, and also we would like to input the OpenNFB our requirement and specifications. And this is initial target of OpenNFB. Currently, initial target is expanded to the whole of the manual functionalities. So. And this is figuring out the gaps. Of course, there is gaps because of the OpenStack is deployed and originally made for IT industries. So from telecom operators' point of view, there are gaps. So we filling out or narrow. We want to make narrow these gaps. At first, we would like to introduce our fault management requirements into OpenStack. So this is we call it adapter because of we would like to be fixed, and we would like to how can I say if error occurs, we would like to fix it as soon as possible. So we call it adapter, and there is 6 blueprints and also 1 patch, and these are already introduced to a Newton release, so you can download from OpenStack site and you can use the adapter functionality in OpenStack. And the second one is the promise. That is the requirement project on resource preservation. So. And currently, we are struggling to promote this kind of functionality into OpenStack. So there are several ways to achieve such kind of functionalities. So soon you can use and you can download this functionality from outside. And this is the challenges and expectations for SDN-enabled the NFV. First, the interoperability among vendors in NFV and SDN, and gaps between chip systems requirements and IT cloud specs that I already mentioned, and OEM functions in the expanding SDN from intra-DCs into inter-DCs, and unified federation for multi-layer networks. That is quite important for using the such kind of functionalities in single operation, and also the it can be enabled or introduced by automation. And also expectation is enabled NFV could bring flexible network with high availabilities. And this was the press release, and we introduced the NFV technologies in our commercial networks this year's March 9th, and this was the battery PC functionality was provided by NEC and Fujitsu. Fujitsu is the Fujitsu and Nokia's collaboration, and also our platform was introduced and they are provided by Ericsson, and our SDN network and SDN controller and so forth provided by Cisco. And from now on, I introduced our expectation for future core network system, and this shows our evolution of mobile communication system. So from upper side, there are the portable phones, and at first we call it the shoulder phone. So it was like a shoulder breaker, but it was quite the impressive and good solution. And after that, of course, the mobile phone to be the more smaller and smaller. And this is time plan for 5G. And we want to make 5G launch in 2020. It means in 2020 we will have Olympic Games, so it is quite important years. So we would like to introduce 5G network and 5G systems in commercial network in 2020. And we think this kind of the 5G is achieved by a phased realization. So at first, we would like to introducing 5G new route, and after that, we would like to more expand. We would like to expand such kind of functionality and such kind of system to more higher and wider frequency bands, and also to make and to keep the compatibility with the existing networks, and also deployment and migration scenarios like that. In 2020, 5G will be launched initially from areas where higher performance is required. And beyond 2020, deployment areas for 5G are gradually expanded, and also frequency will be expanded as well. And there's a need and demand in future core networks. A lot of versatile services, as you know, and also a very, very low latency in specific services like a BSX, remote surgery, or remote operation of drones, and etc. And a huge number of devices for IoT like that. And also, we would like to expect not only to connect 5G RAN, but also this means we would like to migrate the existing network into 5G RAN, and also the end user expecting us reasonable price. That is the very important things. So how we can achieve such kind of think is the network slicing can accommodate versatile services in a single network. So we think the network slicing is quite important for achieving 5G network at reasonable price. And this slide shows the future network key enablers. Of course, NFV-SDN is one of those, and network slicing and session separation. This means the cloud-native applications, and also C-plane and U-plane split, and edge computing is also needed, I guess, for the very short latencies. And also routing optimization is also needed, we think, because if those kind of technology will not introduce into the 5G systems, then it takes more and more the latencies. And this is we did in this June in this year. We had POC in 5G world, and also this introduced by collaboration with our the partner company, and this is the press release. And this is the NGMN, from NGMN, and we proposed this kind of the three-layered architecture with our partner vendors. And this is FutureWorks for NFV. FutureWorks for published interface GSs. And OBNFV accelerate promise projects. That is for our project. So we would like to accelerate that kind of project. And also a future core network. Gap analysis between needs in future core network and the current NFV states is needed. And also harmonize common understanding of network slicing, because there are a lot of the definition and the salt for achieving network slicing, and also network slicing itself. So network slicing, and we think network slicing and NFV are key enablers for future core network. Then, and therefore, that is quite important for the standardization of network slicing is needed in no-related SDOs for achieving end-to-end network slicing. So before that, we would like to this kind of the before that, I would like to mention this second grade of second grade. The harmonized common understanding of network slicing is quite important for achieving such kind of the standardization, and also the harmonized the common understanding. And this is summary. Stage 2 works for important interfaces in Vimano are almost done. Stage 3 is ongoing. And codes from Doctor project in OBNFV have been implemented and integrated in OpenStack Newton release already, so you can use it. And there are some future works in NFV, OBNFV, and future core network, especially common understanding of network slicing is needed. Yep, that's my presentation. Thank you for listening. 谢谢大家。